So now we'll see the classification of micro instructions. Actually, we can implement this micro programming in two ways. So based on the micro instruction type. So one is vertical micro instructions, second one horizontal micro instructions. If you use vertical micro instructions, then we say that is vertical micro programming. So if you use horizontal micro instruction, then we can say that is horizontal micro programming. However, both are micro programming, but there is a difference between vertical micro instructions and horizontal micro instructions. We will see that. So let's say this is whatever you have studied so far is actually horizontal micro instruction. So where there is an alternative called vertical micro instruction, I will tell you. So whatever so far I have explained you, that is vertical micro instruction. Vertical micro instruction will have two components. One component it generates control signals. Second component will sequence the next instruction. That means after that next set of control signals are where, that will be decided by next instruction, right? So this is called horizontal micro instruction. Now the drawback of horizontal micro instruction is, here example, let's say in your machine there are 64 control signals. That means there are 64 places where we can generate the signals. Okay, example, did you remember? Just for clarity I am giving, for multiplexers, for every multiplexer in your circuit we have to have one signal, right? Similarly for program counter, there is a signal called program counter enable, right? In that way. So these are all control signals. Assume that one hypothetical machine has 64 control signals. So then if there are 64 control signals, we don't know which signal should be activated at any point of time. That's why each word, if you see each word, so this portion, if you focus, this is micro instruction, right? So each micro instruction, if you say here to here, should have 64 length, correct? Because to generate 64 signals at, sometimes, you might require to generate 64 signals at a time. Then 64 bits are required, right? Minimum 64 bits. So that is what, we have done in horizontal micro instructions. So now if you see, sir, what is the problem here? You have 64 control signals to generate them. So 64 different entities are required, right? So, but the problem is, when you have 64 positions like this, for next instruction, sir, what is the size of next instruction, by the way? I will tell you. That depends on your control memory, right? So assume that, let's say, your control memory contains some, it depends on your micro operations. Assume that there's, let's say, this memory size is 256 words, okay, 256 words. To uniquely differentiate the 256 words, then how many bits are required? 8 bits. So there are 256 different locations. To identify them, 8 bits are required. So overall your control word, I can say this entire thing is control word. So the size become 64 plus 8, 72, correct? Otherwise your complete micro instruction word, entire thing is 72 bits, right? Can we reduce it is the question. If you can reduce it, then probably we can reduce the space of this memory, because this memory is precious, because we are going to embed this entire memory in a chip, a small chip which is close to CPU, right? So that is what we are not going to store this entire data whatever we have in main memory. We are not storing in main memory, we are not storing in disk. If that is the case, then you don't bother, otherwise you don't require to bother about saving the space. Since you are creating this memory or designing this memory which is related to CPU board, right, then the size should be as less as possible, okay, so that if the size is less, even the accessing also will be speed. That's why my target is reducing this control memory size. How to do that, sir? By reducing the number of bits per control signals. Sir, how can you do that? Because 64, even your machine, it requires 64 control signals sometimes. But there is a trick here. Though there are 64 positions where you require signals, so they might not be, generally the experience says that generally you might not require all the signals at a time. Okay, so example, see the situation. Out of 64 signals, let's say you require only one signal at a time. That means, so depends on the micro operation. In one micro operation, you have to enable only, otherwise you have to assert only signal C1. There is a second micro operation. So that micro operation requires only enabling or asserting signal 2 or C2 in that way. So each instruction, micro instruction, require only generating at most one signal, let's say. Okay, otherwise exactly one signal, either C1 or C2 or C3, so on. Then how many different patterns are required? Still we use horizontal model first of all. So maybe you require this pattern where C1 is on, all other bits are off, right? Like this. So this is one possibility. Second one, you get this binary pattern 0 1 0 0, all the remaining zeros. So each one, let's say 64-bit word, right? 64-bit. But you see, since my assumption is at a time exactly one signal should be on, then how many different combinations are possible? Only 64. You know that, right? Only 64. Then what we do is, rather than using 64 bits like horizontal micro instruction, we can do some optimization here. What is that optimization is? Only use 6 bits. Okay. Now use a decoder, and in digital you have studied decoder. So this decoder can take 6 bits as input and it can generate one of the 64, like it can generate 64 patterns. Such a way we can design a decoder, right? So if you give 6-bit input, then it can generate 64 different signals. Okay, so I mean it can generate one of the pattern out of 64 in that way. So we can generate, I can say, 6 to 64 decoder. So what is going to happen because of that? That 6 bits will be converted to one of the 64 patterns. Understand? Example, let's say same thing I will explain for 4 bits. Example, let's say you have 4 signals. Okay, 4 signals. But at a time only one signal is active. Then how many different patterns are possible? Maybe 0001, 0010, 0100, otherwise 1000. Correct? Only 4. Then we can create a decoder which will take 2 bits as input, right? So that is going to be any 2, right? So example, let's say 00, 01, 1011. What we have to do is, we have to plan this decoder such a way that when the input is 00, then it should generate 0001. If the input is 01, then it should generate 0010. If the input is 10, it should generate 0100. If the input is 11, it should generate 1000. In that way, we can plan a decoder which is 2 by 4 decoder. 2 patterns are converted to 4 patterns, right? So, I mean 2 bits are converted to 4 patterns. Yes, it is possible. Understand? But the only thing is, again you require a decoder circuit that will have some delay. That's why here generate. Now how to generate that 64-bit code word we will see. We will be having now control word like this. In that, this will be 6 bits. This will be next address. Okay, next address is as it is, we are not disturbing, but these 6 bits are connected to a decoder. That decoder will generate one of the 64 patterns like original one, right? Now before this decoder we used to have 64-bit patterns directly, but here now from now onwards in the memory we are only maintaining 6-bit pattern. But later when you execute the instruction, that means whenever you take the word from the memory, after taking that from the memory, we have to connect it to decoder and we have to generate a 64-bit pattern. Understand? So sir, every time we can do it, right? So why for only for this example? Because here you have only 64 patterns. Now let us try to use the same thing. Example, let's say, see this scenario. You have 64 signals, but you don't have clue which signal will be generated at what time. Okay, at any time, any number of signals can be active. Let me clearly write it. At any time, at any operation, okay, any signal can be active. In any operation, any signal can be active. Signal can be active. If that is the case, then how many patterns are possible? If that is the case, it's like a mathematical problem. You have 64 signals, right? 64 bits. At any time, any bit can be active, then 2 to the power of 64 combinations are possible. Why? I will tell you. Let us solve this problem for 3 bits. Example, let's say you have only 3 signals. At a time any number of signals are active, then how many different patterns are possible? Maybe 0 0 0, no, nothing active, 0 0 1, 0 1 0, 0 1 1, everything is possible, right? Then you get 2 cube possibilities. Now your decoder, to generate 2 to the power of 3 possibilities, it requires 3-bit input. Here also, to generate one of the 2 power 64 possibilities, then your decoder requires, recall, so your decoder to generate 2 power 64 possibilities, it requires 64 bits. So that's why we can't do any optimization. This will be the best one, right? So, but generally it is not the case. Generally what is the case? Though you have lot of control signals, we don't really require everything at a time. Understand? Example, I mean, I can relate it to your, you know, your daily activity also. Okay, in your life, generally, maybe you have lot of devices, right? You have phone, you have TV, you have fridge, right? You have laptop, in that way. But you tell me, at a time, how many devices you use? At most one, right? So similarly here also same thing. That is what I am saying. Here also, in that case, if example, though you have lot of signals, only few signals are present in this bit, I mean in the word, then we can go for optimizing by using vertical micro instruction, correct? So this is about horizontal versus vertical. Now, using this point, there are a lot of gate questions. We will solve them. So by that time, you understand everything. Now, let me compare these 3 ideas. First of all, we started with what? Hardwired control unit. We have designed control unit by using hardwired, right? Hardwired mechanism. Second one, we have designed control unit using horizontal microprogramming, correct? Microprogramming using horizontal. Third one, we have used microprogramming using vertical. Which one is fastest and why it is fastest? You tell me. Definitely the circuit will be faster, right? Why? I will tell you. So in the memory model, we are taking example in the circuit model. What were we doing? Example, to perform one micro operation, automatically at that time that circuit was generating the signals. But here what is happening? To perform one micro operation, then we have to go to one word, micro word, right? We have to take it and we have to keep it in, your control data register. After that, we have to generate the signals, correct? For that we have to give it to, circuit again. So there are 2 levels, right? First of all, we have to fetch the instruction from the memory. After that we have to generate the signals. But here directly circuit itself is generating the signal. That's why hardwired control unit will be faster than horizontal, otherwise microprogramming first of all. Now we'll compare horizontal versus vertical. Which one is faster? Definitely horizontal. Why? Because in horizontal, directly after fetching the instruction, micro instruction, we are simply generating the signals, right? But in vertical microprogramming, after fetching the micro instruction, we are not directly able to, we were not able to directly generate the signals because we will be using compact form, correct? Because of this compact form, what happens? We have to give that to a decoder again. So that decoder has to generate the control signals, right? So that's why I can say that again there is a delay because of the decoder, one more level. So that's why, so the fasterness, if you see, definitely hardwired is good, then horizontal, then microprogramming. So vertical microprogramming is the slowest one, right? Sir, why then people still prefer hardwired faster? Then second question, sir, why people don't prefer hardwired? In which cases we should not prefer hardwired? The problem with hardwired is, suddenly you want to add a new instruction, then we have to collapse the circuit and we have to start from the scratch. And at the design level, once you design a circuit, if you want to do any modification, it will be very difficult. But in microprogramming, if you want to add any new instruction, okay, otherwise if you want to add any new control signals, and if you want to, why we want to add new control signals, maybe you want to add new equipment to your circuit. When you add new equipment and new signals, then we can change the program. That means, in the memory, what you do is, I will tell you in the high level, this is your memory, right? Directly go to memory and modify some of the bits. Example, you had a new signal and you want to generate a new signal in some particular instruction. Then you change the program. By changing the program, we can generate more signals and new signals and whatever we can do, right? It's like a software kind of thing. So if I ask one question, which one is good, like hardware or software? Definitely software will have flexibility. Similarly here also, because of the software, I can say not exactly software, it is called firmware. So this memory model, whatever you are using, because of that you get flexibility, but at the cost of speed. Now, sir, what is the difference between vertical and horizontal? Where is the difference? The only difference is you are using compact form in the vertical micro instructions. Because of that, it is adding more delay. But what is the advantage it is giving? It is reducing your memory size, correct? So we are going to keep all the micro instructions in memory. So if you take vertical micro instruction and horizontal micro instruction, which one will be relatively lengthier? Definitely horizontal, correct? So vertical micro instruction will look like this, correct? Because of that, then what is going to happen? We can reduce because we are going to keep these instructions in the memory, so memory size will be decreased. When memory size is less, then access will be faster. That is what the idea. So that sometimes you might not have that much space which is near to your CPU, correct? That's why we have to always reduce the space requirement. That's why we go for vertical micro instructions. But again, trade-off. When you go for vertical, then we require one more level of decoding. Because of that, it will become slower. Understand? This is all about control unit design, right? Initially, let us summarize. Initially, we started with what? Just circuit, right? Your processor, and we have understood processor and how to design it, right? Like we have seen data path also. After data path, what I taught, after that I slowly explained you that we need signals, control signals to activate at appropriate times for proper execution of the instructions. But how to generate the control signals? For that we learn control unit design. Control unit is going to generate control signals. We can do with three techniques. One is hardwired, second one microprogramming. In microprogramming we have horizontal, second one vertical. This is all about control unit and instructions design, right? So now what we do is we solve a lot of gate questions. Now I hope definitely if you attend these lectures up to this point, every gate question you will be answering from hardwired, I mean any control unit, okay?